Welcome, my dear student, in our math program for Secondary 3. Dear student, today we are taking the first lesson in calculus. Remember, the first lesson, its title, Limits. What is the limits? Dear student, remember, limits we were studying the last year. Limits when x tends to 0. In function, when x tends to infinity, when x tends to any number. Remember, look at the introduction of limits. Limits. The limit of a function defined by more than one formula. Theorem. Limit f of x when x tends to a equals L if and only if f of a negative equals f of a positive equals L. Remember, dear student, limits of f of x when x tends to a equals L if and only if these conditions. What is the condition? F of negative a or a negative equals f of a positive equals L. Example, f of x equals two branches. The first x plus 2 when x more than 1, x negative 2 when x smaller than 1. Find limit f of x when x tends to 1. Dear student, remember we have function has two branches, x plus 2 when x more than 1, x negative 2 when x smaller than 1. Find limit of f of x when x tends to 1. Solution. Look at, dear student, the opposite graph represents the previous fraction. The previous function f of x equals x plus 2 when x more than 1 equals x negative 2 when x smaller than 1. First, we find f of 1 positive. Look at limit when x tends to 1 positive. We substitution about x equal 1, 1 plus 2 equals 3. Answer, f of 1 negative. We substitution about limit function x negative 2 by using x equals 1, f of 1 negative equals negative 1. Remember, dear student, f of 1 positive equals 3. But f of 1 negative equals negative 1. Then, what did you deduce? Yes, f of 1 positive equals or not equals, good student, not equals f of 1 negative. Therefore, the function has no limit as x tends to 1. Another example. Function f of x equals x plus 2 when x more than 1, 3 when x equals 1, x negative 2 when x smaller than 1. Look at, dear student, f of x has no limit as x equals or tends to 1, although it is defined at x equals 1, but f of x has no limit. Another example, f of x equals 2x plus 1 when x more than 1 and smaller than 3, x power 2 minus 2 when x more than or equal 3, smaller than or equals 5. F of x equal 5x when x more than 5 and smaller than 7. Discuss the extents of limit of f of x when x tends to 1. Number 2, limit f of x when x equals 3 or tends to 3. Limit f of x when x tends to 5. Now we are translate to the solution. Number 4, find limit f of x when x tends to 7. Solution. Look at the opposite figure. We divided the graph into 5 parts. Smaller than 1, interval from 1 to 3, interval from 3 to 5, interval from 5 to 7, and interval from 7 to infinity. Between 1 and 3, what is the function? So the condition when x more than 1, smaller than 3, function equals to x plus 1. When x included between 3 and 5 or belongs to closed interval 3 and 5, function f of x equals x power 2 negative 2. When x included between 5 and 7, f of x equals 5x. Dear student, when we find limit f of x when x tends to 1, limit x tends to 1 positive, we substitution about x equals 1. 2 times 1 plus 1 equal 3. Number 2, f of 3 positive. By substitution about it, x equal 3 in x power 2 minus 2. Answer is 3 power 2 9 minus 2 equals 7. F of 3 negative equals 2 times 3 plus 1 also equals 7. What you deduce, dear student? Yes, excellent student. F of positive 3 equals f of negative 3 equals 7. Then limit when x tends to 3, f of x equals 7. When we find f of 5 positive, limit when x tends to 5 positive, substitution about x equals 5. 5 times 5 equals 25. F of 5 negative, substitution about x power 2 minus 2. X power 2 minus 2 equals 23. Remember, f of 5 positive 25, but f of 5 negative 23. What you deduce? Excellent student. F of, yes, 5 positive not equals 5, f of 5 negative. Then f of x has no limit as x equals 5. F of 7 negative, substitution about x equals 7 in 5x. 5 times 7 equal 35. Then limit f of x when x tends to 7 equals what? 35. Another example. Let function f equals x power 5 minus 1 over x minus 1 when x more than 1. 1 over x plus 1 when x more than 1 smaller than 1. Cosine x when x more than negative y over 3 and smaller than 0. Discuss limit f of x when x tends to 1, limit f of x when x tends to 0, limit f of x when x tends to negative y over 3. Solution. Dear student, look at the opposite graph. We have 3 functions between negative y over 3 and 0, f of x equals cosine x. When x included between 0 and 1, f of x equals 1 over x plus 1. When x more than 1, f of x, yes, equals fraction function x bar 5 minus 1 over x minus 1. F of 1 positive, substitution about x equals 1 and limit f of x when x tends to 1 positive equals x power 5 minus 1 power 5 over x minus 1 equals 5. F of 1 negative equals limit f of x when x tends to 1 negative. When substitution about x in 1 over x plus 1, answer is half. Dear student, f of 1 positive not equals f of 1 negative. Then what you deduce? F of x has no limit as x equals or tends to 1. F of 0 positive equals limit when x tends to 0, 1 over x plus 1 equals 1. Substitution about x equals 1, 1 over 1 equals 1. F of 0 negative, substitution about, yes, x equals 0 and cosine x. What is the cosine 0? Equals 1. What you deduce, dear student? Yes, f of 0 positive equals f of 0 negative equals 1 equal f of x. Then what you deduce? Yes, f of 0 positive equals f of 0 negative equals 1. Then limit x tends to 0 of f of x equals 1. When we find limit f of x when x tends to negative y over 3, by substitution about x equals negative y over 3 and limit cosine x. Dear student, remember cosine negative y over 3, yes, equals cosine y over 3. What is the rule in first secondary school? Cosine negative equal cosine positive. Cosine pi over 3 or cosine 60 equals 1 over 2. Remember, dear student, look at another example. F of x equals x absolute value x minus 2 plus 5. Discuss the existence of each. Limit f of x when x tends to 2. Number 2, limit f of x when x tends to 5. Solution. Look at f of x. Dear student, we have absolute value x minus 2. Then we solve the absolute two branches. X multiply x minus 2 plus 5 when x more than or equals 2, and negative x multiply x minus 2 plus 5 when x, yes, smaller than 2. F of x becomes x2 or x squared minus 2x plus 5 when x more than or equals 2. Negative x power 2 or negative x squared plus 2x plus 5 when x smaller than 2. Look at the opposite figure. Yes, when x more than 2, f of x equals x squared minus 2x plus 5. When x smaller than 2, f of x equals negative x squared plus 2x plus 5. When find f of 2 positive, substitution about it, yes, x equals 2, then 4 minus 4 plus 5 equals 5. F of 2 negative, substitution about x equals 2 in the left function, negative 4 plus 4 plus 5 equals also 5. Dear student, what you deduce? Yes, we deduce f of 2 positive equals f of 2 negative. Therefore, limit f of x when x tends to equals 5. When we find limit f of x when x tends to 5, by substitution about limit x equals 5 in the right function, x power 2 minus 2x plus 5 equals 25 minus 10 plus 5 equals 30 minus 10 equals 20. Look at, dear student, another example. F of x equals x squared minus 5 absolute x over x power 2 or x squared plus 6x plus 5. Find limit f of x when x tends to 0. Number 2, limit f of x when x tends to 1. Number 3, limit f of x when x tends to negative 1. Solution. Dear student, look at the function is f of x equals fraction function x power 2 minus 5x over x squared plus 6x plus 5 when x more than or equals 0. The second branch is f of x equals x power 2 plus 5x when x power 2 plus 6x plus 5 when x smaller than 0. The function becomes, yes, when we find f of 0 positive, by substitution the right function about x equals 0, the answer is 0 over 5 equals 0. Also, f of 0 negative, by substitution about x equals 0, the answer is 0. What you deduce, dear student? Good. F of 0 positive equal f of 0 negative, then limit f of x when x tends to 0 equals 0. When we find limit x tends to 1 f of x, by substitution about x equals 1 in right function. By substitution about x equals 1, the function becomes 1 minus 5 over 1 plus 6 plus 5 equals negative 4 over 12. Then limit f of x when x tends to 1 equals negative 1 over 3. Also, when we find limit f of x when x tends to negative 1, by substitution about x equal negative 1 in, yes, left function, because negative 1 smaller than 0. By substitution about x equals negative 1, the answer is 1 negative 5 over 1 negative 6 plus 5 equals negative 4 over 0, and find has no limit when x tends to negative 1. Another example. F of x equals 3x plus absolute x minus 2 over 2 minus x when x smaller than 2, 4x minus 1 when x more than or equals 2. Discuss limit f of x when x tends to. Solution. Dear student, remember absolute value. We have two branches. Any absolute value, x minus 2 equals 2 minus x when x smaller than 2. Then f of x becomes 3x plus 2 minus x over 2 minus x when x smaller than 2, and 4x minus 1 when x more than or equals 2. F of x equals 3x plus 1 when x smaller than 2, 4x minus 1 when x more than or equals 2. Then becomes function absolute. After we solve absolute, the function is changed. F of x becomes equals 3x plus 1 when x smaller than 2 and 4x minus 1 when x smaller than, bigger than or equals 2. Look at the opposite figure. F of 2 positive by substitution about x equals 2 in right function in the graph. 4 times 2 minus 1 equals 8 minus 1 equals what? 7. F of 2 negative by substitution about x equal 2 when left function. Therefore, f of 2 negative equals 3 plus 3 times 2 plus 1 equals 6 plus 1 equals 7. Therefore, f of 2 positive equals f of 2 negative equals 7. Therefore, limit f of x when x tends to, yes, exist and equals 7. Remember, dear student, when we find limit f of x when x tends to 2, or when we find f of x when x tends to 2, remember, we must prove f of 2 positive equals f of 2 negative. In last example, f of 2 positive equals 7. F of 2 negative equals 7. Then f of 2 positive equals f of 2 negatives equals 7. Dear student, look at another example. F of x equals 2 branches. The first 3x over 10x when x more than negative pi over 3 smaller than 0. 3 cosine x when x more than 0 smaller than pi over 3. What is the pi? 180. Discuss the existence of number 1, limit f of x when x tends to negative pi over 3. Number 2, limit f of x when x tends to 0. Number 3, limit f of x when x tends to pi over 3. Solution. Dear student, the opposite graph represents the function when x included between negative pi over 3 and 0, f of x equals 3x over 10x. When x included between or more than 0 smaller than pi over 3, f of x 3 cosine x. Limit f of x when x tends to negative pi over 3, substitution about x equals 3 pi over 3, negative pi over 3, 3 times, yes, pi over 3 over 10 negative 60 equals negative pi over negative root 3 equals pi over root 3. Number 2, f of 0 positive. In this case, dear student, when we find limit f of x when x tends to 0, we must find f of 0 positive and f of 0 negative. If 0 positive equal f of 0 negative, then limit f of 0 is exist. By substitution about x equals 0 in 3 cosine x, 3 times cosine 0. What is that cosine 0? Equals 1. 3 times 1 equals what? 3. When we find f of 0 negative, by substitution about x equals 0, 3 times 0 over 10, 0. In this case, dear student, we doesn't substitution about x equals 0. Why? Because we have a rule. Limit when limit x tends to 0, 3x over 10x divided each term or numerator and denominator by x. Limit, yes, when x tends to 0 negative equals 3 over 10x over x. Remember, what is the limit? Yes, 10x over x equals 1. 3 over 1 equals 3. We have important rules. Remember, when limit function f of x when x tends to 0, sin x over x equals 1, tan x over x equals 1. The last year we were studied these important rules, very important. when we find limit tan x over x when x tends to 0 equals 1, limit sin x over x when x tends to 0 also equals 1. Dear student, look at another example. F of 0 positive equal f of 0 negative equal 3. Limit f of x when x tends to pi over 3. By substitution about x tends to pi over 3. Why? Because cosine pi over 3 equals cosine 60. What is the value of cosine 60? Good, equal half. Then, therefore, 3 times cosine pi over 3 equal 3 times half equal 3 over 2 or 1.5. Dear student, look at the important example. F of x equals ax plus b, x smaller than 2, ax squared minus b when x more than 2. If limit f of x when x tends to equal 3, then find the value of a and b. Remember, dear student, we have function has two branches, ax plus b when x smaller than 2, ax squared minus b when x more than 2. If limit f of x when x more than 2 or tends to, yes, equal 3, find the value of a and b. In this example, dear student, limit f of x is exist equal 3, but we find the value of a and b. Solution. Look at the opposite graph. Limit f of x when x is tends to equal 3. By substitution, yes, f of x is exist at x equals 2 or x tends to 2. Then what is the condition, dear student? F of x equals 3 when x tends to 2. Yes, excellent student. F of 2 positive equals f of, yes, excellent student, 2 negative equals 3. By substitution about x equals 2 in right function and in left function, and we substitution to find a and b. Look at, dear student, f of 2 positive equal 3, f of 2 negative equal 3. Then, dear student, by substitution about x equals 2 in right function, then 2 power 2 for a minus b equals what? Equal 3. This equation number 1. F of 2 negative equal 3. What is the condition? What is the function of 2 or equation 2? By substitution about x equals 2 in left function, 2 times a plus b equals 3. We have, yes, two equations. The first, 4a minus b equal 3. Second, 2a plus b equal 3 by using omitting method. Insert the prep. Remember, dear student, two function, we find the value of a and b by using omitting method. Therefore, yes, adding 1 and 2, 6a equals 6, then a equals 1. In equation 2, 2 plus b equals 3, b equals 3 minus 2 equals also 1. Dear student, I am very happy to spend such time with you. Remember, math simple, think, work, produce. Goodbye.